Hi, dear students. Welcome back to my session. Um, in our previous sessions, we discussed basic laws and the analysis techniques and conversion, star to delta and delta to star. And we solved many problems on that chapter. So, as of now, we finished only chapter 1. Means on the chapter 1 we covered like let me revise that topics: junction, branch, loop, and limitations of Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law. And we solved many problems on KCL and KVL law. We explained the mesh analysis and nodal analysis. With the nodal analysis with the supernode also we explained in our last class. And we solved simple problems on mesh analysis and nodal analysis. And we done with the star to delta conversion derivation and delta to star conversion derivation. And we solved many problems on this star to delta and delta to star circuits. And we developed these formulas, transformation formulas for the star to delta transformations. And we solved many problems on the mesh analysis also. So that is chapter 1 about this chapter 1. Now we are moving to the chapter 2. That chapter 2 which deals with the DC network theorems, I can say network theorems. In this chapter, the very important thing is theorems. So what are the theorems which we are going to be discussed in our further sessions? Let me say those names: superposition theorem, Thevenin's theorems, and Norton's theorem, maximum power transfer theorem. uh, that's it. This is as per your syllabus. And there are, if you go for the graduation, there are few more theorems are uh, Tilligan's theorem, some theorems are like that. So those theorems are not comes here. If you move to the in graduation level, you may have 2 to 3 theorems more compared to this. So in this, and in parallel with, we will discuss problems also. But before discussing those theorems, there are some basic concepts which is required for the working about the theorems. We need to be discuss about the ideal sources like ideal current source and ideal voltage source and the source transformation techniques. These 3 topics we need to be discussed in this class itself. Before moving to the theorems, we need to be discuss was ideal sources like ideal current and voltage source, and source transformation techniques means ideal voltage source to ideal current source, or ideal current source to ideal voltage source, means vice versa. So let me move to the next slide. So right, before discussing the ideal voltage source, let's see the practical voltage source, how the practical voltage source is there. Compare a practical voltage source to an ideal voltage source. But what is the meaning of ideal voltage source? Ideal voltage source is nothing but the source which have the internal resistance is 0. Means there is a no resistance value. The resistance value through that ideal voltage source is 0. In this, if you observe this diagram, this is the ideal voltage source. This is the ideal. Let me add marker. This is the ideal voltage source. This is unloaded ideal voltage source. If you connect any resistance across this A and B terminals, that is a loaded ideal voltage source. So, but compare a voltage source to an ideal voltage source. The voltage across its terminals A and B remains fixed regardless of the value of load resistance that may be connected across its output. So means ideal means it is not depend upon the load resistance. Either may be high resistance or low resistance, that doesn't matter. About that source is called ideal voltage source. But practically this is not possible. We have all the practical voltage sources itself only. So if you look in detail, this is a practical voltage source. Rs is the internal resistance, and Vs is the source voltage. This is a Vs, because if you see the practical voltage source, there is an internal resistance is there. But here there is no internal resistance. If you observe this, there is no internal resistance here. Means the internal resistance is 0. If meaning of Zero means there is no value of resistance across the line, means there is no indication of resistance through that line. So if you look at this slide, let me clear the few points about the ideal voltage source. The voltage source is ideally provides the constant voltage to the load even when the load resistance is varies. Means if you connect the load resistance across this pointer, let me add this. If you connect the load resistance across this, even the load resistance is varies, means like this variable. If this based on this changing of voltage, based on the changing of resistance across this A and B terminals, there is a no changing of voltage. In reality, no voltage source is ideal, means in practical purpose, in the way of practical, this is not possible of the ideal circuits. Means there is no resistance is zero in practical sources, because there's some internal value of resistance is there, like 0.0005 ohms value of resistance may be present in the mode of internal. But in practical, in practical this value is exists, but in ideal this value will become a zero. That is the reason I included this point. In reality, no voltage source is ideal. Voltage source have some inherent internal resistance represented by Rs. This is a supply resistance. When a load is applied to the source, not all the voltage appears across RL, since some of the voltage is dropped across RS, because there is a resistance is present here. Because of the resistance presence here, there is no voltage Vs is not appeared across this output value. I will be drawing this circuit. Let me. If there is a no value of resistance here, means if this value is zero, let me assume this is a ideal. Means the definition of ideal voltage source itself, the voltage source which has zero internal resistance is called ideal voltage source. Please guys, remember this definition is very important. What is the definition of ideal voltage source? The voltage source which has zero internal resistance is called ideal voltage source, right? So this point means when a load is applied to the source, means like this. If let me observe this diagram, already the load is given. When the load is applied to the source, sorry, applied to the A and B terminals, it the complete voltage Vs will not appear across the load. That what this point says. Why? Because there is a drop is happening across this Rs, because resistance is present between voltage source and the load, that is Rs. Due to this internal resistance, there is a drop maybe exist, that is called ISRS drop. Hence, the total voltage will not present across A and B. So some drop will be appear maybe less than this Vs. Means my output voltage always less than the Vs. This is called practical voltage source. When my output voltage is equals to the input voltage is called ideal voltage source. When this case will be occurred, when my internal resistance is zero, then only if I connect any DMM across this A and B, my total voltage will be appear across the DMM is Vs, because my internal resistance is zero. That is the reason the small difference between ideal voltage source and practical voltage source. In the practical voltage source, the internal resistance will be present. Due to some minute value of the resistance that can be measured in sometimes a very low value of resistance like 0.05 or sometimes 0.005. But some value of resistance is present in practical voltage sources. But in ideal voltage sources, there is no value of resistance. I can name it as a resistance is zero. If let me move to the next point. If Rs is very small as compared to the RL, means supply resistance, the source approaches to the ideal, because almost all of sources voltage Vs will appear across the large resistance Rs. If even though this is small of resistance R, sometimes the source will be equal, the output value of resistance may be equal to the input value of resistance, input value of voltage. So this is about the practical. So this is about the ideal voltages. In detail, we will observe clearly. Let me add some paint. Then we will some working on the paint. Then you can understand clearly. Let me move to the paint app. Let me move. Let's see ideal voltage source first. Then we will see ideal current source. Let me write clearly. Ideal voltage source. This is the ideal voltage source. Let me here the voltage source Vs and the internal resistance is Rs. Between these two terminals, I'm going to be connect the internal the load resistance is RL. Just assume this is RL. I'm connecting between these two terminals, RL. Current through this load is I. Voltage across the load is, sorry, let me this is a current through this load is I, and voltage across through load is V. Right, already you know this terminology. This is V or V naught. I can name it as a V naught. This is positive sign, this is negative sign. Now if I write the KVL of this loop equation, means like this, the leaving sign uh, Vs, I'm writing, sorry, KVL, my loop equation. Let me write the loop equation for this. Already you know how to write the loop equation. The leaving sign is plus Vs. I am writing directly Vs minus IRs minus V. This is the output minus V naught. V naught is equals to 0. Right? I used to follow leaving sign. This is positive and this is a negative. So from here I wrote like this. So hence V naught is equals to Vs minus I Rs. This is equation 1. Let me write this is equation 1. So this is equation is very similar to V naught is equals to Vs minus I Rs, right? So this is the equation in the form of straight line, which is in the form of y is equals to mx plus c. Let me write in in that way. Mx plus c means, let me write this equation. V naught is equals to mx is nothing but a minus rs into I plus c is nothing but a vs. So this, let me compare these two equations. Y is nothing but a v naught, x is nothing but a I, m is nothing but a minus rs, c is nothing but a vs. So if I draw the slope line, here the slope is m is minus rs. If I draw the VI characteristics of the circuit, then means terminal voltage versus load current, then sorry, this is V, this is I, this is called VA characteristics. In this equation, I'm comparing with the slope equation. Y is equal to mx plus c. Then if this is terminal voltage Vs versus load current IL or I, right? Not terminal voltage, not Vs output. If in this equation I is 0, in this equation I is 0 means when I is tends to the 0, then terminal voltage is equals to V naught is equals to Vs. There are two cases which are possible. The first case, let me write the first case. In this equation 1, when current is 0 means when the current will be 0, when my load resistance is removed, then the current is 0. At the times the V naught is equals to how that value will be exist. Let me see. When the current is 0, V naught is equals to Vs. V naught is equals to, when the current is 0, this term is going to be 0. V naught is equals to, when V naught is 0, case 2, V naught is 0. What about my I? I will be, my I will be Vs by Rs. Be clear. So In this point, I'm going to be showing these points on this VA characteristics. When my output voltage V naught is equals to the means V, this is the output voltage V naught. When my output voltage is equals to the supply voltage, at which condition I is equals to 0, when my current is 0, then only the output voltage is equals to supply voltage. If this is case 1, what about the case 2? When my output voltage is 0, means when my output voltage is 0, this Vs is tends to the 0, then my current through this complete circuit is, when my then at the time my currents flowing through the circuit is means V naught is equals to 0, then it will comes to the right side, then I will be Vs by Rs. So these terms are very important. So I'm going to be show these points in this in this graph. Then let me draw this. V naught is Vs for this when my current is 0. At point of current is 0, means current is 0. Let me show that in different lines. Sorry. Right. When first case 1, current is 0, then V naught is equals to Vs. V naught is equals to Vs. This is Vs. Right. Current is 0, this is Vs. This is not exactly V naught. Let me remove that. Means that is source current. Output terminals. Just I am going to be drawing with between voltage and current only. This is not output. This is only voltage. And then it becomes Vs or V naught. Same line, same axis for this both V naught and Vs. Instead of mentioning Vs, you can mention V naught and Vs. For the both, the line is same because the units are same now. That is the reason. So this is Vs for this. At the case 1, I is equals to 0. What about the case 2? V naught is equals to 0, means when the V naught is 0, right? This is 0. What about the I? I is equals to Vs by Rs. So some of the line may be present. I is equals to Vs by Rs. The point is Vs by Rs. If you make a joint of these two lines, let me add these two lines. Then you will get some slope. This straight line which is slope sorry, slope is means m. The slope name is called minus, sorry, slope is called minus Rs. The slope is called minus Rs. Hope you understand what I'm trying to say. The slope is called minus Rs because m of the slope. If you observe this, the slope as the value of current increases, the terminal voltage is decreases. If you observe this point, you will understand. This is comes from the category of practical voltage source. Whatever I am discussing, this is practical voltage source. If comes to the ideal voltage source, for ideal voltage sources, let me write that terminology. For ideal voltage sources, IVS, the internal resistance means Rs is equals to 0. When Rs is equals to 0, my terminal voltage means V naught is equals to Vs. Hence, this terminal is going to be 0. Means supply voltage is equals to the output voltage. Then the graph will be like this. Let me remove this. then my graph will be this. Let me draw that graph. This is graph for the ideal voltage source. Means in this case, in whatever the value of current changes, because the current is 10 to the 0, my internal resistance is 0. For that, there is no flowing of current. Then V naught is equals to 0. There is, instead of changing of any current, if you increasing of current from 0 to infinity, the value of voltage is constant. That is called practical. That is called ideal voltage source. So let me write, this is V naught is equals to Vs. Means output voltage is equals to supply voltage, or terminal voltage is equals to Vs. It means in this case V is equals to V naught is equals to terminal voltage is constant at any value of load current. Hope you understand. What is the slope? Slope is 0. Of this point there is no slope. So ideal voltage always provides the constant terminal voltage of any value of load current. Sorry, load current or load. So now let's see the current source. Hope you understand. So this is about the ideal voltage source. Please try to observe this y vi characteristics diagram. This is very important. The green line indicates the ideal, and this line indicates the saffron line indicates the practical. Please try to observe this diagram. In this diagram, in this VA characteristics, we drawn two. One is ideal, one is practical. When that practical will be ideal, when my internal resistance is 0, on that condition, the my practical voltage source will be performed as an ideal voltage source. So when my ideal voltage source, we have these in practical voltage source, we have two cases. One is for I naught, I is equals to 0. Second one is V naught, means terminal voltage is 0. When my internal when current is equals to 0 means the removing of the supply. So the removing of load. In this condition, the current will not flow in the open circuit, right? So then V naught is equals to, if I connect across this DMM across this A and B terminals, it will show same output to voltage as a input voltage. Here this is for case 1. In this case 1, I got 1 point. I represent this point in y-axis. Let me say v-axis, and that is one case 1. In if I move to the case 2, V naught is equals to 0 means when the maximum there is minimum value of resistance is there. In that condition, the maximum current which will flowing through this resistance. Hence my V naught is equals to 0. Output voltage, when my output voltage is 0, then I is equals to Vs by Rs. Output voltage 0, I is equals to Vs by Rs, means that is short circuit conditions. These two conditions are this is minimum, this is extreme conditions. In this condition, I drawn one line. That this line, this straight line is indicates the slope of minus Rs. This is for practical. When practical will be ideal in this case, in which case means Rs is equals to 0. When my internal resistance 0, this. When the internal resistance is 0, in that case only my practical voltage source will be work as a ideal voltage source. So in this condition also, I drawn with this slope y is equals to mx plus c. Then in that there is no slope, then y is equals to c, means output voltage is equals to the input voltage. Then v naught is equals to v0. Here there is no slope. That is the reason I indicated 0. Right. So let me move to the next slide. In this, we will discuss ideal current source. Let me write the name. me draw the circuit diagram. This is current source IS, which have the internal resistance. Sorry, which have the internal resistance. This is RS. You see, this is CD terminals instead of AB. Already we mentioned AB in ideal current, ideal voltage source. That is the reason I'm mentioning ideal current source as a CD. So this is RS is the internal resistance. This two is two terminals. So in this between terminals, between these two terminals, the load RL is connected. Let me connect. Between these two terminals, load RL is connected. It's RL. Let me write the load current is I. Load current is I. Let me indicate the current. Load current is I. Let me remove this lines, or else you will confuse about these arrows. Right. Load current is I, and the terminal voltage plus and minus will be mentioned as a V0 or terminal voltage. You can name it as anything. V0 or terminal voltage, both are same across this load. Now apply the KCL. Apply KCL at V, which is mentioned here. Already you know. Because this is opposite direction, minus IS, right? Three currents which are flowing through this. One is exactly opposite, minus IS, plus VS by RS. Same current which is flowing through my assumption direction, that is this side. Is equals to 0. Then the equation will be I is equals to, the equation will be I is equals to I plus, sorry, I S plus VS by RS. Sorry. One moment. I is equals to IS plus VS. Sorry. I is equals to IS plus VS. Now let me write that VS by RS. Right? From here, if you write in this equation, I is equals to if you write in this equation of this IS, this is not IS, this is I, sorry, this is I, this is IS. This is IS, let me write that. Yes. But if you're writing with the representing y is equals to mx plus c, you need to be dependent upon this. This is comes under the in a different category. Then you are writing I is equals to minus 1 by rs into vs plus is. So here, this equation is, let me write this equation is 2. This is not vs, this is v. Wait one moment, let me correct this. This is vs. Let me remove this. This is v, not vs. This is v. This is v, means this voltage, your assumption voltage v. Right. Means if you compare this equation with my slope equation, y is equals to mx plus c. Let me write that equation. Y is equals to mx plus c. Y is equals to mx plus c. Here, my slope here. My slope is m is equals to minus 1 by rs. Now let me draw the load current versus voltage. Here we have two conditions. When voltage is zero, here the case one is when the voltage is zero. In this equation, when the voltage is zero, then I is equals to IS. This is V. This is I. Sorry. For the writing of this, V and I. When load current is zero, means this will be zero. Then it will be IS is equals to, sorry, V is equals to IS into RS. Wait. V is equals to Is into Rs. Then let me draw this currents equations, these cases in this graph. When voltage is zero, let me draw the points clearly. Please observe here. When this is, we have two cases. One is at voltage is equals to zero. This will be tends to be zero. Then I is equals to I. This is case one. In case two, my load current is zero. Means this current is zero. Then when the load current is zero, at which condition this may be happens, when my output terminal, my load RL is removed, then at that condition only my load current will be zero. Then my supply voltage will be Vs. My output voltage means V of this indication of this V is equals to Is into Rs. This voltage will be appear across C and D terminals. So let me indicate these points in this x and y axis coordinations, right? X and y axis. So let me first, in case one, when my voltage is zero, this voltage is zero, my I is equals to Is. Let me add this I is equals to Is, right? Then when current is zero, like this, when current is zero from this point, this point is 0, 0 means V and I. This points V, I. When current is zero, V is equals to Is and Rs. So that point maybe comes here. V is equals to Is and Rs. I can write directly. Instead of V, I am going to be write Is and Rs. Yes, multiply with Rs. If you join these 2 points, let me join those 2 points. This is the slope. The slope name is called, this is the slope. What is the slope name? Minus 1 by Rs. This slope is called, sorry, let me write the slope. This slope is called minus 1 by Rs. As soon as they increase the value of current, my voltage is slowly decreasing. Please observe this point carefully. So from here, this is the practical voltage source. So now, how you will make it is in ideal voltage source? If let me write, for ideal current source, when the ideal current source will comes to the picture, when my internal resistance Rs is equals to 0, in this condition only the ideal current source will be comes to the picture. This condition is very important. When my internal resistance is 0, sorry, not 0, infinity, sorry, let me remove that point, that my internal resistance is infinity, in that condition only this circuit will work as a ideal current source. Means the when this Rs is tends to the infinity, then my output current is equals to the input current. If you substitute this Rs is equals to infinity in this equation 1, how my equation will be comes to the next step? This is equation 1. Substitute this Rs is equals to infinity, means if you substitute infinity over here, it means 1 by 0. Then this entire value is tend to this 0. Then my supply voltage is equals to input voltage, means I is equals to Is. Means there is a case will come to the picture when this is practical voltage source, means there is no utilization in this internal side. Complete whatever you are giving input current, means if you're giving 10 amps from your generating station, the 10 amps will be comes to your load. There is no dropping at all. That is called ideal case. In this case also same. Rs, when the Rs is equal to infinity, means internal resistance of the circuit is infinitive, then the circuit is called ideal current source. Again, I am going to be repeating, when my irrespective of voltage. So let me draw that slope in this, means I is equals to IR. Let me draw that. For the any value of voltage, my ideal current is doesn't change, means the current value is same. If you change the voltage from 1 to many millions billions of value of voltage, my current will always constant. So for that, you can draw the diagram in this axis like this. Any value of, sorry, let me add this, any value of voltage, my current always constant. So this is the graph of ideal. So any value of voltage, let me add these points of voltage. Let me, if you are adding of 1 volt, my current is constant. 2 volts, my current is constant. 100 volts, my current is constant. 1000 volts, my current is constant. 1 lakh volts, my current is always constant. So there is no changing of currents in VI. So some books they used to mention like this graph. They given I here, and they used to given current voltage over here. They will get a graph like this. In that mode, that is also correct, because he changes the coordinations, means they take it as a y-axis as a current and x-axis as a voltage. But here I'm not changing. In my ideal voltage source also I used same coordinations, means we y-axis is voltage and x-axis is current. In that graph itself I used to draw this diagram. So this coordinations, from this the current is constant even though the voltage is varies from 0 to many infinity. So that is the reason, when the ideal current sources comes to the picture, when the resistance of the internal is infinitive, in that condition only my ideal current sources comes to the picture. So this is not possible in practical way. That is the reason they mentioned as a ideal current source. Hope you clear. This is very important. Please try to understand carefully. Please again, if you any doubts, please rewind this video and try to start from the initial stage of this. So now I'm going to be show these two graphs in two ideal sources in one graph. Let you observe. This is voltage, this is current. First let me draw the graph of ideal voltage source. This is for, is the here the, is there any slope? Slope is 0 for this. Slope is 0. This is for ideal voltage source. Then let me draw the ideal current source. Means in this ideal voltage source, V is equals to Vs. Output voltage, let me draw that line carefully. This is V naught is equals to Vs. Output voltage is equals to input voltage. V naught is equals to Vs. Then what about This is ideal current source. This is ideal current source. This is ideal voltage source. Let me show that point clearly. I is equals to I means I naught or I load, both are same. You can, instead of mentioning I, you can mention I naught or you can mention load current. This both are same. I is equals to Is means supply current. Load current or output current is equals to supply current, is called ideal current source. So here if you observe these two lines, green and blue, whatever you are changing the current value, please first observe the green line. Whatever is changing the current value from here to here means 1 amp, 2 amp, 3 amps, 4 amps, 100 amps, 100 amps, 1000 amps, the voltage value will not change. Means constant, always maintaining the constant. So that is case only comes under ideal voltage source. So that is the reason you should, in the ideal voltage source, the resistance is zero. When my current value is going to be very, when my resistance is changing, the current is going to be changing, because the drawing capability of current is depend upon the resistance value. If the resistance value increases or decreases, my current value changes. That is the reason in this point I clearly mentioned the resistance of this ideal voltage source is zero. Means it is independent of the current. Whatever the changing of the current, because I did the resistance zero, then current always depend upon the resistance. When my resistance is zero, the value itself is not changing of the voltage drawing, because the voltage dropping is multiplied with the resistance and current now. When my resistance is zero, then there is no voltage drop. For the voltage drop formula, V is equals to I into R. When my resistance is zero, there is no voltage drop. V is equals to IR. If this is a voltage drop VD, in this VD you should, for the finding of VD, you require two terms, uh, two parameters. One is current, one is resistance. If one of the parameters is 10 to the 0, then there is no voltage drop. Since there is no voltage drop, my voltage drop is nothing but V naught is equals to voltage drop, sorry, V input is equals to output plus losses, right? Means V output plus losses. When my losses will be tends to the 0, always Vi is equals to V output. That is the reason when my resistance is 0, that condition is comes to the ideal voltage. So this is practical not possible, just for the sake of important conversations and for the next topics. So I am going to be discussing in detail. So what about the ideal current source? In the ideal current source, resistance is infinite. Means there is a value of infinity of value of resistance. Even though my changing of the voltage from 0 to infinity value of voltage, my current will doesn't affect, right? My current will does not affect, right? So R is equals to infinity, then my input current will be flowing through entirely through the load. So this is the about this, and hope you clear about this ideal sources. So we will mm, discuss in further classes for the conversions, for the source conversions. Means non voltage sources, non practical, non ideal voltage source is nothing but a practical voltage sources to be converted into the practical current sources, or vice versa. How that conversions is going to be made based on the derivation, we will observe in our next class. Thank you for your time. Thanks for your patience. Bye bye.